What is an assembler? Well, what it does, it reads in a program written in an assembly language and converts it to native machine code. Load A14 is one example of an assembly instruction. An assembly language is a type of low-level programming language that is intended to communicate directly with a computer's hardware. Unlike machine language, which consists of binary and hexadecimal characters, assembly languages are designed to be readable by humans. As I have mentioned, the assembly language is designed to be readable by humans and not by computers, which only knows binary. So, in order to convert this text-based programming language into binary machine code, we need an assembler. This assembler reads the text-based instructions and converts it into binary form, which will be then loaded into the memory of the computer. Over time, assemblers gained new features that made programming even easier. One nifty feature that you should know about is automatically figuring out jump addresses. This was an example program I used in the previous courses, and notice how our jump negative instruction jumps to address 5 and our regular jump goes to address 2. The problem is, if we add more code to the beginning of this program, all of the addresses would change. And that's a huge pain if you ever want to update your program. To overcome this issue, the assembler doesn't use raw addresses. Instead, it lets you insert little labels that can be jumped to. When this program is passed into the assembler, it does the work of figuring out all of the jump addresses. Now the programmer can focus more on programming and less on the underlying mechanics under the hood, enabling more sophisticated things to be built by hiding unnecessary complexity. However, even with nifty assembler features like auto-linking jumps to labels, assembly languages are still more appealing to human eyes than machine code. In general, each assembly language instruction converts directly to a corresponding machine instruction, a one-to-one mapping. So it's inherently tied to the underlying hardware. And the assembler still forces programmers to think about which registers and memory locations they will use. If you suddenly needed an extra value, you might have to change a lot of code to fit in it.